Okay, we'll look at some of the review problems that will be on exam number 3, which will be on Tuesday, November the 1st. And what you'll see on this review sheet will be similar to the problems that will be on your exam. And as always, you will have a help sheet to assist you with these types of problems. In problem number 1, you want to find the coordinates of the vertex of the parabola f of x is equal to x plus 4 quantity square minus 11. All right, this particular equation is written in standard form, and of course standard form in this case is going to be f of x is equal to a times x minus h quantity square plus k. And in this case, the vertex is always h and k. Okay? Now in this case here with the h, you always take the opposite sign. Since it's plus 4, that h will have to be negative 4. Because of the standard form is in the form x minus h. And we have x plus 4, so that means that the 4 has to be negative. And the k is whatever that sign is. Minus 11, that's going to be negative 11 for your k. So your vertex will be negative 4, negative 11. Okay? And that's all you have to do there is just find the vertex of that particular parabola. Negative 4, negative 11. All right, number 2, you're going to use the formula x equals negative b over 2a to find the coordinates of the vertex of the parabola. In this case, f of x is equal to 5x squared minus 30x plus 21. In this particular case, we need to identify a, b, and c. Well, just a and b. A is the number in front of x squared. That's your 5. The b is the number in front of x. That's negative 30. So here, we'll use negative x equals negative b over 2a. And just replace the b and the a with those values. Here b is negative 30, so we got negative of negative 30 divided by 2 times a, which is 5. Well, negative of a negative 30 is 30, divided by 2 times 5, that's 10. And if you do 30 divided by 10, you'll get 3. So the x-coordinate of this vertex will be 3. Now we need to find the y-coordinate of the vertex. In this case, we'll replace the 3. Well, we'll put the 3 in place of x in this f of x equation here. So we'll evaluate f of 3 by replacing each x with 3. So we have 5 times 3 to the second minus 30 times 3 plus 21. And then we'll just simplify. In this case, 3 to the second is 9. 9 times this 5 is 45. Minus 30 times 3 is 90 plus 21. Now, if we do 45 minus 90 plus 21, we'll end up with negative 24. That negative 24 represents the y-coordinate of the vertex. So here, the vertex for this particular parabola will be 3, negative 24. So that represents the vertex of this particular parabola. All right, number 3, we're going to do the graph of the quadratic function f of x is equal to x squared minus 2x minus 3. And we're going to perform the following. You're first going to determine whether the graph opens upward or downward. Part B, identify the vertex of the parabola. Part C, find the x-intercepts. Part D, find the y-intercept. And Part E, sketch the graph using the intercepts, vertex, and additional points. Okay, we'll start with Part A, determining whether the graph opens upward or downward. And we do that by identifying the A, which is the number in front of your x squared. In this case, is 1. If it's positive, the graph will open upward. If it's negative, it's going to open downward. In this case, A is equal to 1. It is positive, so that means that the parabola opens upward. So that's part A. Part B is identifying the vertex of that parabola. It's written in general form, so we need to identify A, which is 1, and B, which is -2. That's the number in front of your X. And we have to use X equals -B over 2 times A. And in this case here, the B was -2, so we have negative of -2 divided by 2 times A, or 2 times 1. Simplify that, that'll be 2 over 2, which is 1. So the x-coordinate of that vertex is 1. Now to find the y-coordinate of the vertex, we replace each x in this f of x equation with 1. So in this case, f of 1 would be 1 squared minus 2 times 1 minus 3. 1 squared is going to be 1 minus 2 times 1, which is 2, minus 3. So we got 1 minus 2, that's -1. -1 minus 3 is -4. So the y-coordinate of that vertex is -4. So the vertex is 1, -4. That's my x-coordinate, and that's my y-coordinate of the vertex. 1, -4. Part C. Find the x-intercepts. Well, if we want to find the x-intercept, we want to set this particular function equal to 0. So we have x squared minus 2x minus 3, which is my f of x. I'm going to set that equal to 0 and solve for x. Here we got a trinomial that can be factored into 2 binomials. And in this case, x squared, I'm going to break that up as x and x. The only factors of -3 that will give me -2x as a middle term will be -3 and plus 1. So we got x minus 3 times x plus 1 equal to 0. And then we set each binomial factor equal to 0. So we set x minus 3 equal to 0, x plus 1 equal to 0. And then from there we go ahead and solve for x for each equation. So for x minus 3 is equal to 0, you'll have x is equal to 3. And then for x plus 1 is equal to 0, you'll have x is equal to -1. So my 2 x-intercepts will be at 3 and -1. Okay, part D is finding the y-intercept. The y-intercept, we let x equal 0. So we'll just evaluate f of 0 by replacing each x with 0. So you have 0 squared minus 2 times 0 minus 3. So in this case here, 0 squared is 0, minus 2 times 0 is 0, minus 3. 0 minus 0 is 0, minus 3 is -3. So the y-intercept is at -3. Now we're going to take all of this and do the graph. Because we're going to sketch the graph using those intercepts, the vertex, and any additional points. We know that the vertex is 1, -4. So here we go to 1, go over 1 and down 4 and draw the point. If you want to, you can draw your axis of symmetry. The axis of symmetry always crosses the vertex. And that axis of symmetry, of course, is x is equal to 1. This is a vertical line that crosses the vertex. And then my 2 x-intercepts are at -1 and 3. So I'm going to draw a point at -1 on the x-axis and a point at 3 on the x-axis. My y-intercept is -3, so we go to -3 and draw the point. Now, if we need an additional point, we can compare the distance from the axis of symmetry to that y-intercept. That y-intercept is one place to the left of the axis of symmetry. So that means that the other point has to be one place to the right of the axis of symmetry. Okay? Here that y-intercept is one unit to the left of the axis of symmetry. The other point to the right of that axis of symmetry must be one unit to the right, because symmetry means that the left side is the mirror image of the right side. So these are all the points that I need to draw the graph of that parabola, which is, of course, f of x is equal to x squared minus 2x minus 3. Okay, question number 4. When given this quadratic function, f of x is equal to negative 4x squared plus 160x minus 600, and you want to perform the following. You want to determine, without graphing, whether the function has a minimum value or a maximum value. Then part B, find the minimum or maximum value and determine where it occurs. And C, identify the function's domain and range. All right, let's look at part A. We want to find out whether we have a maximum or a minimum value by looking at what A is. A is the number in front of your x squared. That's negative 4. And negative 4, of course, it is negative. It's less than 0. So that means this particular function will have a maximum value. Because if you think of the curve, the highest is going to be opening downwards. So that means we're going to have the highest point there. So we do have a maximum value. Part B, let's find out what that maximum value is and where it occurs. We need to identify A, which is, of course, negative 4. B is the number in front of your x. That's 160. And, of course, we use x equals negative b over 2a to determine where that maximum occurs. Just replace the a and the b in this formula. We got negative b, which is 160, divided by 2 times a, which is negative 4. So now you get negative 160 divided by 2 times negative 4, which is negative 8. Negative 8 into negative 160 will go 20 times. So the x is 120. So we know the maximum occurs at x is equal to 20. But to find the maximum value, we replace each x in this f of x function with the 20. So here, f of 20 will simply be negative 4 times x, which is 20, and that's squared, plus 160 times x, which is 20, minus 600. Now let's simplify this. 20 squared is 400. 400 times negative 4 is negative 1600. Plus 160 times 20, that's 3200, minus 600. Now, let's do negative 1600 plus 3200 minus 600, and you'll get 1000. So here the maximum value is 1000 when x is equal to 20. Okay, so we found the maximum value, which is 1000, and it occurs when x is equal to 20. Now part C is identifying the function's domain and range. Now the domain is going to be quite simple, because any value that you assign to x, you're always going to get an f of x value for it. So in this case here, it's going to be the set of all x such that x is a real number. Now, preferably interval notation, negative infinity to infinity. In fact, that's the answer that I will expect you to do when you write this, the function's domain and range. They have to be in interval notation, negative infinity to infinity. Now for the range, we're dealing with a maximum value. So we know that the highest value it will be is 1000. Okay, and notice I'm putting the brackets at 1000. Okay, so here it has to be negative infinity, because what the maximum value must be from negative infinity up to that maximum value. If it was minimum, then it will be whatever that minimum value is to positive infinity. But in this particular problem, negative infinity to 1,000 represents your range. All right, question 5. Use the leading coefficient test to determine the end behavior of each polynomial. In part A, you get f of x is equal to x to the 5th plus 17x to the 3rd minus 11. We're going to identify a sub n, and we're going to identify n. Let's first identify the n. The n is the highest exponent in this problem. That's going to be 5. So in this case, your n is going to be 5. A sub n is the coefficient of the variable with the highest exponent. That, in this case, is 1. Now let's compare n and a sub n. N is odd because n is equal to 5. A sub n is 1 and it's positive. So that means, in this case, your f of x, the end behavior means that it's going to fall to the left and rise to the right. That's the end behavior for this particular graph in part A. Now, you do not have to do this, but if you wish to put in that equation in the calculator yourself, you will see what that end behavior would look like. Okay. That's part A. Now part B, we got f of x is equal to negative x to the 6th plus 7x cubed plus 2x squared minus 8x minus 12. In this case, your a sub n and n is 6. That's the highest exponent. A sub n is negative 1. That's the coefficient of the variable with the highest exponent. Here, n is even, but a sub n is negative. So that tells us that the graph of f of x will fall to the left and to the right. F of x falls to the left and to the right. Okay. Question 6. Here we're going to find the zeros for the polynomial function f of x is equal to 3x, 3 times the quantity x minus 2 squared times the quantity x plus 5 raised to the 3rd, and give the multiplicity for each zero. And here you want to state whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. Okay? The function is already factored out for you, so what we're going to do is take each binomial factor and set it equal to 0. So we'll set x minus 2 equal to 0, and we'll set x plus 5 equal to 0. Now here, x minus 2 is equal to 0. We'll find out what x is, and we see that x is equal to 2. And then for x plus 5 is equal to 0, we'll have x is equal to negative 5. So the zeros of this function will be 2 and negative 5. Now we want to state whether the graph crosses the x, well, find the multiplicities first. The x equals 2 comes from x minus 2. Its exponent, in this case, is 2. So x equals 2 has a multiplicity of 2. Now for the x equal negative 5, that came from the x plus 5, and its exponent is 3. So that means that x equals negative 5 has a multiplicity of 3. Now we need to state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. Well, x equals 2 has an even multiplicity because 2 is an even number, so that means that x is equal to 2. That means that the graph of f of x touches the x-axis and turns around. At x is equal to 2, the graph of f of x touches the x-axis and turns around. Now for negative 5, we have an odd multiplicity of 3. So that means at x is equal to 5, with an odd multiplicity, the graph of f of x crosses the x-axis. Okay, and that's all there is to it. Okay, so you want to state the zeros, identify the multiplicities, and state the behavior at each 0. Question 7 is using synthetic division to divide the following: x to the 4th minus 30x squared minus 5x plus 90, and that's divided by x plus 5. Now here's how we set up the synthetic division. Our divisor must be of the form x minus c. In other words, the c will have to be whatever this constant is. We got x plus 5, so in order for it to be x plus 5, the c has to be negative. So our divisor is going to be negative 5. And keep in mind, the divisor is going to be the opposite sign. Now, let's see if there are any missing terms here. In this case, there are missing terms. We got x to the 4th, and then we're going down to x squared. We're missing an x cubed. So here, for x to the 4th, this coefficient is 1. But for x cubed, since it's a missing x cubed, we need to put a 0 there. And then for x squared, it's negative 30. For x is negative 5. And then for your constant is 90. And keep in mind, any missing terms, you must put a 0 to compensate for that missing term. Now we can begin the synthetic division process. We bring down the first number or the leading coefficient in the bottom row, and then multiply 1 times negative 5, which is negative 5. That negative 5 goes underneath the 0. Now you'll add 0 and negative 5 to get negative 5. Then we'll continue the multiplication and additions until all the columns are filled. So negative 5 times negative 5 is 25. Add negative 30 and 25, you're going to get negative 5. And then negative 5 times negative 5, again, that's 25. Add negative 5 and 25 together, you're going to get 20. And then finally, 20 times negative 5 is negative 100. 90 plus negative 100 is negative 10. Okay, so that completes that. Now, the last number in the last row is always going to be your remainder. The remaining numbers in this particular problem represent the quotient. That quotient is always one exponent less than the highest exponent of our dividend. Here our dividend was x to the 4th. So that means that this quotient will start off as x to the 3rd. So the coefficient of 1 will be x to the 3rd. Well, 1 will be the coefficient of x to the 3rd. Minus 5 will be the coefficient of x squared. Another minus 5, that's going to be the coefficient of x, plus 20. And then our remainder will be minus 10 over the divisor of x plus 5. So this is what your quotient and your remainder will be. X cubed minus 5x squared minus 5x plus 20 minus 10 divided by x plus 5. Question 8. Again, we're going to use synthetic division, but this time we're going to use the remainder theorem to evaluate this particular function. F of x is equal to x cubed minus 4x squared minus 3x plus 27. 4x is equal to negative 5. Okay, so here x equals negative 5. That's going to be our divisor. Now notice there are no missing terms because we have x cubed, x squared, and x and a 27, and a constant. So here the coefficient of x cubed is 1. The coefficient of x squared is 4. The coefficient of x is negative 3. And the coefficient and the constant is just 27. And here's where we do the synthetic division process. We bring down the 1, which is our leading coefficient in the bottom row. And then we'll do 1 times the divisor of negative 5, which will be negative 5. And then we add 4 and negative 5 to get negative 1. And then negative 1 times negative 5 is 5. Then add negative 3 and 5 together, you're going to get 2. And then 2 times negative 5 will be negative 10. And then add 27 and negative 10 together, you'll get 17. As always, the last number in the last row represents your remainder. Not only that, that remainder represents what the value of this function is at x is equal to negative 5. So we can say that f of negative 5 is 17. And that's all we had to do right there. All right, question 9. List all the possible rational zeros of the function f of x is equal to 2x cubed minus 9x squared plus 4x minus 18. Okay, so here we're going to list all the factors of a sub 0, which is in this case negative 18, because that's the constant. And then the factors of the leading coefficient, a sub n, which is 2. Okay, the way I do this, I list all the factors in pairs. So we'll start with negative 18, and we're using plus or minus symbols here. So for 18, we'll have plus or minus 1 and plus or minus 18 as a pair of factors. Another pair will be plus or minus 2 and plus or minus 9. And then plus or minus 3, plus or minus 6. I know 4 can't go into 18 and 5 can't go into 18, but 6 can go into 18, which is 3 times. But I do have 3 and 6 as my factors. So here, these are all the factors of negative 18. Now for 2, the only pairs of factors for 2 will be plus or minus 1 and plus or minus 2. Okay, now let's list all our possible rational zeros. The numerator is always the factors of the constant term. So I'll list those in order. That's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. That's going to be divided by the factors of my leading coefficient, which is a sub n. That's plus or minus 1 and plus or minus 2. Now, I'm going to divide each factor in the numerator by each factor in the denominator. Okay? The 1 is going to be easy because 1 divided into each one of those in the numerator will be these numbers here. So I'm going to rewrite this as plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. I mean, you could go through each one of these one by one. So that means 1 divided by 1 is the 1 plus or minus 1. 2 divided by 1 is plus or minus 2. 3 divided by 1 is plus or minus 3. 6 divided by 1 is plus or minus 6. 9 divided by 1 is plus or minus 9. And 18 divided by 1 is plus or minus 18. Now, we're going to take these same factors in the numerator, divide each one of those by 2. So now, 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is plus or minus 1, which I already have. So I'm not going to rewrite that again. 3 divided by 2 is plus or minus 3/2. 6 divided by 2 is plus or minus 3. I already have plus or minus 3, so I'm not going to rewrite that again. 9 divided by 2 is plus or minus 9 halves. 18 divided by 2 is plus or minus 9, which I've already have right here. So these are all the possible rational zeros of this particular polynomial function. And you're asked to go no further than this. Question number 10. Determine the equation of the vertical asymptote of the rational function f of x is equal to 5x plus 17 divided by x squared minus 36. In this case here, to find the vertical asymptote, we set our denominator, which is x squared minus 36, equal to 0, and solve for x. Well, x squared minus 36 is a differences of squares, so I can factor that into x minus 6 times x plus 6 equal to 0. And then set each binomial factor equal to 0, so you have x minus 6 equal to 0, x plus 6 equal to 0. And then solve for x for each equation. So for x minus 6 equals to 0, you'll have x is equal to positive 6. And then for x plus 6 equals 0, you'll have x is equal to negative 6. So 6 and negative 6 represents the vertical asymptotes for this rational function. Those will be the vertical dotted lines that will cross the x-axis at 6 and at negative 6. Okay, question number 11. Now here is the you have to follow the 7-step procedure to graph the rational function f of x is equal to 4x squared over x squared minus 9. Okay, here's the 7-step procedure. You first determine whether or not this graph has symmetry. And we do that by replacing the x with negative x. And when we do that, you have negative 4, and then negative x will be squared. Well, not negative 4, just positive 4, and then negative x will be squared. Then negative x will be squared minus 9. If you get the original equation back, you'll have y-axis symmetry. That means that the graph will be symmetric about the y-axis. If the equation is the opposite of the original equation, then that means we have origin symmetry. Otherwise, we have no symmetry. So if we simplify this, negative x and u squared will be x squared. And the same thing here, negative x squared, that will be x squared minus 9. Notice I got the original equation that I started off with. So that means that this rational function has y-axis symmetry. That means it's going to be symmetric about the y-axis. Number 2, we want to find out what the y-intercept is going to be. We simply replace the x with 0, so we're going to put 0 in this place. So you have 4 times 0, and that's squared, over 0 squared minus 9. Well, the numerator, 0 squared is 0, times 4 is 0. 0 squared is also 0 minus 9, that's negative 9. 0 divided by negative 9 is 0, so the y-intercept is going to be 0. That means that the rational function, the graph, will cross the y-axis at 0. Now let's find the x-intercept. The x-intercept, we let the numerator, which is your 4x squared, equal to 0. And when we simplify this, 4x squared is equal to 0. You divide by 4, x squared is equal to 0. Then for x, the only number squared will give you 0 is 0. So in this case, your x-intercept is 0. Okay. And then number 4, finding the vertical asymptote. And I should say asymptotes, if any, because there may be more than one. We take our denominator, which is your x squared minus 9, and set that equal to 0. So set x squared minus 9 equal to 0 to find out what our vertical asymptotes are going to be. Okay, we can factor this into x plus 3 times x minus 3 equal to 0, and then set each binomial factor equal to 0. So you have x plus 3 equal to 0, x minus 3 equal to 0, and then solve for x. So here, for x plus 3 is equal to 0, you have x is equal to negative 3, and then for x minus 3 is equal to 0, you'll have x is equal to positive 3. So negative 3 and positive 3 are my vertical asymptotes for this parabola. For this rational function. Now number 5 is the horizontal asymptote. Now we have to use that rule of identifying n and m to determine what our horizontal asymptote is going to be. N is the highest exponent in the numerator. Here's our equation. The highest exponent in the numerator is 2. That's your n. The m is the highest exponent in your denominator. That's also 2. So n is 2, m is 2. Compare n and m. They're both equal. So we have to use the equation y is equal to a sub n divided by b sub m as our horizontal asymptote. A sub n and b sub m are your leading coefficients in the numerator and the denominator, respectively. So here, the leading coefficient in the numerator is a 4. In the denominator, the leading coefficient is an understood 1. So it'll be 4 over 1, which will be 4. So the equation y is equal to 4 is your horizontal asymptote. Now, 6 and 7 I'm going to do together, because number 6 is going to be the table, and we'll use our calculator for this, and then number 7 is the graph. So in this case, let's graph what we already know. We know what the y-intercept is and the x-intercept. They're both the same. It's at 0. My vertical asymptotes are at negative 3 and 3, so I'm going to draw a vertical dotted line at negative 3 and another vertical dotted line at positive 3. And then my horizontal asymptote was y is equal to 4, so I'm going to draw a horizontal dotted line at 4, like this. Okay. Now, I'm going to pick additional points to the left and to the right of each of the x-intercept and each vertical asymptote. My first vertical asymptote was negative 3. Let's pick 3 points to the left, like negative 4, negative 5, and negative 6. And to the right of negative 3, I'll use negative 2, negative 1. And then my x-intercept is 0, so I'll use 1 and 2. And then to my other horizontal asymptote is at positive 3. Let's use 4, 5, and 6. Okay, now this is where we use our calculator to help us out with some of these points. Okay, we go to y equal, and then we press the clear key if you have anything in y1. The numerator is 4x squared. I'm going to use left parentheses, and then 4, then xt theta for your x, and then your x squared button for the exponent of 2, and then close the parentheses, divided by, then left parentheses, For x squared, press the xt theta for your x, and then the x squared button for the exponent of 2 minus 9, close parentheses. And then go ahead and press second and graph, because we want the table. And sometimes you might have to use your up arrow button to get to the values of x that you want, like in this case, -6. Here, x is -6. That means that the y is 5.33. And for x is -5, we see a 6.25. And for -4, I'm going to say 9.1. And then for -2 is -3.2. Now notice at -3 you get an error. That's one of your vertical asymptotes. And then for -1 is -0.5. And as you can see, 0, 0 is your x and your y-intercept. Now let's press our down arrow key to get the other points. Like for 1 is -0.5. And then for 2 is -3.2. For 4 is 9.1. For 5 is 6.25. And for 6, 5.33, or 5 1/3. Notice that the value of y when x is 1 is the same. The y value is the same for 1 as it is for -1. So you can see that there is symmetry. Okay, now let's use these points right here that I've written down in this table off the calculator and put those on the graph. Let's see, -6 and 5 1/3. Go to left 6 and then up 1, 2, 3, 4, 5, and about a third of the way. And then -5 and 6 1/4, or 6 1/4, will be about here. -4 and 9.1 will be a little bit above 9. So I know what one part of the graph is going to look like. It's going to go up like this way, and it's going to come down this way. And then we know what -3 is. So now for -2 and -3.2, -2 to the left, 2 and down, -3.2, -1, and then halfway between, +1 and -1/2, and then 2 and then down to 3.2. And then here's what this part of the graph is going to look. It's going to come down this way on the left, and on the right it's going to be coming down like this. Okay. And then for 4 and 9.1, we know this part is a mirror image of this part, so. And then 5 and 6.25, and then 6 and 5.3. So here's what the other part of that graph is going to look like this. Okay, and this is what the graph of the rational function f of x is equal to 4x squared minus x squared minus 9 looks like. Okay. Right. Question number 12 is finding the equation of the slant asymptote of the rational function. In this case, is x squared plus 7x minus 18 divided by x plus 3. Okay, so we're finding the equation of the slant asymptote. Here we're going to use synthetic division. The divisor is x plus 3. It must be of the form x minus c, so the 3 must be negative. In the numerator, there are no missing terms here. So for x squared, the coefficient is 1. For x is 7, and the constant is -18. Now, when we find the slant asymptote, we use synthetic division, but we drop the remainder, and our quotient represents the equation of that slant asymptote. So in this case here, we're going to bring down the 1 in the bottom row, and then do 1 times -3, which is -3. Then 7 plus -3 is 4, and then 4 times -3 is -12, add negative 18 and negative 12 together, you're going to get negative 30. So we drop this remainder of negative 30. It's these two numbers right here that's going to represent our quotient, which represents the equation of the slant asymptote. Now, we're going to write this with one exponent less than the highest exponent of our numerator. It was x squared, so the 1 would become the coefficient of x, and then the 4 would be your constant, plus 4. And actually, this will be y is equal to x plus 4, because it is an equation of the slant asymptote. So your equation of that slant asymptote is y is equal to x plus 4. And finally, number 13 is a 5-part problem where you're going to be using the graphing calculator. In this case, you're going to use the graphing calculator to make a graph of the equation y is equal to x squared minus 3x minus 6. Okay, so let's use our calculator. We're going to type in the equation. So we'll press y equal. Let's erase this equation by pressing the clear key. And we're going to type in x squared, x, and then the x squared button for your exponent of 2, minus 3x minus 6. And press zoom 6 to be on the safe side. And that is the graph of the equation y is equal to x squared minus 3x minus 6. That's part A. Now part B is to find the two x-intercepts of the function, and we're going to round to the nearest hundred, or to 2 decimal places. In this particular case, we want to find our two x-intercepts. That's this one on the left and the one on the right. So actually, we're finding the zeros of this function, so we want to press second and trace to get the calculate menu. We want to select number 2, which is a 0, because we're finding the zeros of this function. Now we're going to find the one on the left side. With left bound, we use our left arrow key to put the cursor, or the blinking cursor, above that first x-intercept. And then press enter. And then you should get a message that says right bound. You want to press your down arrow key to put the cursor below it. And then press enter. Then after guess, press enter. That's your first 0. Rounded to 2 decimal places, this will be negative 1.37. So your first x-intercept would be at negative 1.37. Now we want to find the other x-intercept, the one on the right-hand side, which is this one. So again, we do second and trace. Select number 2 for 0. Now you want to put the cursor, the blinking cursor, below that second x-intercept using your right arrow key, like I have here, and then press enter. Then for right bound, put the blinking cursor above it, and then press enter. And then after guess, press enter. And we're going to use 4.37 as our x-intercept. So the 0 there will be 4.37. Okay, so that's part B, finding the two x-intercepts. Part C is finding the coordinates of the point where the minimum occurs, and we want to round to the nearest hundred. The minimum is the lowest point on that parabola. So here, we're going to press second and then trace. This time, we want minimum, so we select number 3 for minimum. And then for left bound, we want to use our left arrow key to put the cursor below or on the left-hand side of the lowest point of the graph. The blinking cursor needs to be on the left-hand side of the lowest point of that graph, and then press enter. Right bound, use your right arrow key to put the cursor on the right-hand side of the lowest point of that graph, and then press enter. Then after guess, go ahead and press enter. And that's going to be your minimum to 2 decimal places. We're going to say 1.50 and negative 8.25. And you must write down both ordered, the x and the y. because that's for the coordinates of the point. So the coordinates are x and y. Part D is additionally make a graph of y is equal to 2x minus 3. So here, we're going to add y is equal to 2x minus 3 to this graph. So press y equal. Now hit your down arrow key to go put the cursor at y2. And we're going to type in the equation 2x minus 3. And then press graph. So here we already got the parabola. Now the graph of the line y is equal to 2x minus 3 is included. That's going to help us answer part E. Find the coordinates of the 2 points where the line intersects the curve. In this case, we want to find out where our two intersections are for this graph and the line. There's one here and one here. Let's find the one at the very bottom. So let's press second and trace. This time we're going to select number 5, which is intersect. So select number 5, and it says first curve. What you want to do is put the blinking cursor as close to that first point of intersection as you possibly can. Just put it close enough to it. And then press enter once, then press enter twice, then press enter a third time. And that will give you your first point of intersection. And we're going to round to 2 decimal places, so it'll be negative 0.54 and negative 4.08. And let's see, negative 4.08. That's your first point of intersection. Now we need to find the second point of intersection. That's this point of intersection way up here. So again, we'll press second and trace. And we're going to select intersect, which is number 5. And then that first curve, we want to put that blinking cursor as close to that point of intersection as you possibly can. And you're going to have to use your right arrow key to do that one. And it depends upon where that blinking cursor is. Okay? So put the blinking cursor as close to that point of intersection as you possibly can, and then press enter. Then press enter a second time. Press enter the third time, and you'll have your intersection, which is the ordered pair of 5.54 and 8.08. So here the other point would be 5.54 and 8.08. 5.54 and 8.08. That's your second point of intersection. Okay, so that's how you'll do that last problem, which is going to be dealing with the use of a graphing calculator. Okay, so this should be enough to assist you with what will be on exam number 3, which will be on Tuesday, November the 1st in class, and you will have a help sheet. And if you have any additional questions, please feel free to email me or call me, or you can come by my office during my office hours, and I will be able to assist you.